Today, the Department of Defense has identified one of the principal risks to our economic base and our defense industrial base are castings and forgings. This happened over decades without people such as me even noticing. The challenge of where we hollowed out, though, is it's harder to replicate.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year, but so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now. I'm Noah Scheinbaum, and this is Crossing the Valley.
Hey everyone, today on Crossing the Valley, we are keeping the focus on manufacturing. And to do that, we're bringing in Hank Holland. Hank's an engineer by training. He's a finance professional by trade. And today he's the CEO of Amaero International. Amaero is an Australian origin company that relocated here to the United States, and they manufacture specialty alloy and titanium powders that are essential for our industrial base. Their role is so important that, in fact, just last week, former National Security Advisor H.R. McMaster joined the company as special advisor to the CEO. In this show, Hank and I talk about the state of America's manufacturing capabilities, the role of castings and forgings, and the importance of new forms of additive manufacturing. Enjoy. All right, Hank Holland, the CEO of Amaero International, with us today. Hank, thank you so much for taking time to join us. You're at a fantastic perspective on one of the most important industries in the world at this crucial moment in time. And I know you got lots of thoughts to share with us. Tell folks a little bit about Amaero. What is it that you all do?
Thanks, Noah, and thanks again for taking interest in our story. Amaero International is an Australian ASX listed company that is today, we've relocated today, based in the United States. So we're a US business today. We're focused on the production of C103, which we'll come back to later what that is, specialty alloy and titanium powders that are used in additive manufacturing. So the analog that I would give is we've all got our HP printer, but then it seems like it's always flashing, out of inkjet, right? Out of ink cartridge. We're essentially the ink cartridge to 3D printing or additive manufacturing.
That's a great analogy. The inkjet for 3D printing. You've got a unique perspective given the focus on manufacturing, Hank, and you've talked a little bit about this publicly. You've written about it. American manufacturing is at a pretty interesting moment, right? There's a lot of attention right now. We're it's kind of become almost bipartisan to talk about re-onshoring and strengthening our industrial manufacturing capabilities here at home. I'm curious from your perspective, where are we at as an economy right now on manufacturing? Where's our capacity? Is it where it needs to be?
So it's a really important and a critical question to the national security of our country, as well as the geopolitical backdrop. And perhaps I'm a bit embarrassed to say that prior to 10 years ago, it's not something I was at all focused on, nor was I really have any awareness of the vulnerability this has created at home. I went to college in the mid to late 80s. I was an engineer by education. And then I quickly got into finance. And we celebrated for the next decades globalization. We celebrated all the benefits of globalization. We all learned about real-time supply chains. We all learned about deflationary pressures, right? All of these things, if you will. And so to myself and to many others, we didn't spend a lot of time thinking about what was the trade. What did we give up to create those deflationary pressures, to create those manufacturing and supply chain flexibilities and so forth? And then came along COVID, and immediately COVID was followed by the Ukraine conflict. And I'm happy to spend a bit more time later if you would like. But I think those two world events exposed this incredible vulnerability that we had created from a national security standpoint, but also from a socioeconomic divide standpoint and the unrest in the country that was underlying a lot of these changes. And so from my standpoint, this is as important as anything to the U.S. economy, as anything to the U.S. national security, and as anything to the stability of our social fabric. And by the way, the one thing that I would just close on, if you will, to this point, and I'm happy to pick up, because there's a lot of analogies that go back to World War II that I wasn't all that aware of prior to this. But these are noble, good, skilled jobs, right? And one of the things that we did in my generation and your generation is somehow we discounted the nobility right? And the respectability of these jobs, right? Factory jobs are great jobs. And these skilled tradesmen are great and very, very, very important jobs. And so there's a lot of things I hope that will come from this renaissance that we're having in manufacturing, not the least of which is I hope we all relook at, look, just because you went to a 4-year university isn't necessarily the answer for all of us. We need these other areas. And in some ways, they're far more important than maybe a liberal arts major, other things that we're training. So I think there's a lot of positive to take from it as far as the future of our country, the future of our economic base and geopolitical stability. But it also has exposed a real weakness and vulnerability that we have as a country.
I couldn't agree more. Not only is a 4-year college not for everybody, it's, I think, increasingly less for more people. It's increasingly only for fewer and fewer people. The idolization of the information economy, because that's where popular culture has gone in the last 2 decades, really since the dot-com boom, has meant that, we've seen the political ramifications of overlooking these constituencies, people who could raise their kids, buy their home, have a better life than their parents by working these good manufacturing jobs. And what I wonder, Hank, is, your perspective on that today. Is that something where companies like Amaero, are you trying to bring that back, or are you trying to engage those people in a different kind of economy? I think about manufacturing automation and things that companies like the Hadrians of the world are working on right now. Are we going back to where things were, or how are we? What does the future look like for that sector?
So we're always going forward, and there is no going back. And you look at machine learning, you look at AI, you look at automation, you look at all these trends, but that's not necessarily in conflict with what I suggested earlier, the importance of human capital, the importance of these skilled trades. There's no AI that's going to replace a great plumber. There's no AI that's going to replace a critical welder. And again, I went to a Jesuit high school in Dallas, Texas. It was 102 people, I think, in my graduating class. Almost all the families were working class, middle class families. I'm guessing, I don't know the exact number, I'm guessing 100 of 102 of us went off to university. In my case, I went off to university on engineering scholarship. I never made a choice to go to university. It was never something I had to consider, am I going to go to college? It was just, I just assumed like I was going to go from middle school to high school, that I would go from high school to college. And I think today in society, hopefully that we will get, that others will begin. College is very important for some occupations. And it's a luxury for those of us that got to do it because it's a very enriching experience, right? How great is it to go sit in a philosophy class? How great is it to go sit in a history class? But as far as the ability to go contribute to society, to go play and provide a critical role in critical services, I don't know how much philosophy really adds. And that's where I think Amaero, a big part of what we've got to do now in this manufacturing renaissance, and a big part of our federal policy, candidly, is we've got to train skills for these jobs. And I think it's a real promising thing. And candidly, parts of the country are embracing it far more so than others. I'm a Texan. I was in Texas for 27 years of my life. I was in California for 27 years of my life. In Texas, in Tennessee, in the Carolinas, in Ohio, in Indiana, manufacturing is revered. I don't think that's the case in the San Francisco Bay Area. If you get to these places that are knowledge economies, the knowledge economy and versus the human capital or the human economy, if you will, there's a real divide in our country. And those knowledge economies tend to be on the coast. And those human capital jobs tend to be in the middle of the country.
Yeah. I want to go, the geographic divide is absolutely real. You kind of narrated, you gave a really good overview of how we realized kind of how hollowed out our manufacturing capacity had become with COVID, with Ukrainian war. I wonder if you want to say a little bit more about why. What has happened in the country at a policy and at a kind of systemic and economic level that have resulted in the reduction in manufacturing capability writ large, but even in particular for the defense and national security industries?
And I'll be the first to say, Noah, in many areas, I'm a slow learner. And this would have been one of those areas because my default position is capitalism is good. Right. If you look behind me, you'll see a book of Atlas Shrugged, right? Ayn Rand's one of my heroes, right? I'm a big believer in free market. I'm a big believer in human incentives. And yet, and this is where I would have been slow perhaps on this, and I'm not a big believer in government, and I'm not a big believer in centralized power, but there are important roles for government to play, and this is one of them. And if you think back to economics, we all learned, those of us that had some economic classes, there is a concept of externalities. And what externalities meant is there are certain uncompensated risks. And if you operate purely in a capitalist free market system, the incentive is, how do I run this business for maximum profit? And so if you're a mining company and what you're trying to do is extract as many resources as possible, as quickly as possible, the damage that you do to the earth as a byproduct is not part of that decision. It's a non-economic, it's an externality. If you're a plant that sputters a lot of pollutants into the air, that's an externality. And these externalities create a cost on society. And it could be a direct economic cost, or in this case, what it was a vulnerability. And so companies and well-intentioned management teams, in an effort to maximize their profits, in an effort to maximize their manufacturing, their supply chain process, reduce the inventories they had to carry at any given time, which was a more efficient capital allocation, they began to offshore these capabilities. And of course, this was enabled by software and hardware in the 80s. Right? So now all of a sudden we had ERP systems and way to manage inventory that weren't even possible before. It was enabled by forms of transportation, intermodal forms of transportation that weren't available before, telecommunications that weren't available before. But in doing so, in chasing for efficiency and in chasing for profit, as you described, I think it's a great description, we hollowed out the industrial base of our country. Now, we didn't really notice it, or at least people like me didn't really notice it. And then comes along COVID. So what happened with COVID? You remember trying to get and I forget now the name of the particular mask that we were all trying to get.
N95. That's a good sign that we've forgotten the name of the mask.
Exactly. Yeah, that is a good sign, actually. So N95 mask, and MMM was one of the large producers of those. There was no manufacturing in the U.S. In fact, there was a Honeywell facility in Phoenix, Arizona that the president visited at the time, and they converted this entire factory to make these N95 masks. But all these masks were essentially made in China. Same thing with syringes. All of these medical supplies that we did not have, not to mention, as we've come to find out, a lot of the compounds, the critical compounds, and a lot of our drugs had been outsourced. And the same had happened with these skilled manufacturing jobs. By an example, and this became more clear once we got in the Ukraine conflict. And by the way, to tell a very brief story, and first to shout out a thank you to all of our men and women who are in the armed services. I never served, and I feel a certain guilt for that, having benefited in my life, my freedom, my opportunity for all the hard work of those men and women. And I've always wanted to give back in a very, very small way. The start of the Ukraine conflict, my children are now adults. My youngest is in college. And I watched all these horrendous scenes on TV, these women and children on these train platforms in Ukraine and in Poland. And I said, the heck with it, I'm going to Warsaw. And I went to Warsaw. So this is now March 2022. It's been over 2 years ago, sadly. And within about a week, I had hired some former SAS commandos and stood up something called Project Apollo, which got a fair amount of press. And I did nothing of consequence other than wrote a couple checks. These SAS commandos were the heroes. And with them, we went into Ukraine. I happened to be in Lviv the first night. The first cruise missile came in and blew up a fuel depot about a quarter mile from us. And that night, I'm in my Kevlar helmet, my vest. I'm in this root cellar. And it just becomes clear as day to me, this topic we're talking about. It hadn't occurred to me. Again, I'm a slow learner. It hadn't occurred to me before this, that all I had known in my entire career in my adult life was globalization. And the epiphany was, it's over. It's done. And I now spend the rest of my life winding the clock backwards. And it's those critical capabilities. But one example, and excuse me, I probably won't get the statistic exactly right, but it is on the order of magnitude correct. Boeing at that time, before the Ukraine conflict started, was sourcing approximately 80% of all of its forgings from a company called VSMPO in Russia. 80% of all of the forgings of the largest industrial U.S. company was sourced out of Russia. The Department of Commerce immediately turned off. Today, the Department of Defense has identified one of the principal risks to our economic base and our defense industrial base are castings and forgings. This happened over decades without people such as me even noticing. And by the way, these forgings that I'm talking about, think about a landing gear on a 777 aircraft. These are enormous pieces, and the forging that does is it literally is measured on a Richter scale. It literally shakes the earth. That's how large these forging pieces of equipment are. It's not the type thing you build and assemble in a week or a year or even several years. And so it takes a long time. And to your earlier point, you've got to go stand up the capital equipment, but then you've got to hire the tradesmen. You've got to bring in the skilled workers that have these trades. And these are highly, highly, highly trained workers. We take advantage as we fly across the country, and you look out your plane window down at a field, and we see the round pies, if you will, right? All these irrigated fields in Indiana or Ohio. Farmers today are incredibly sophisticated. GPS located irrigation. The genetics in crops today, the genetics in livestock today, right? We don't think about a farmer as being sophisticated. They're incredibly sophisticated, right? It is an incredibly educated trade. The commoner that's not exposed to it doesn't think of it that way. And the same thing can be said for a welder, for a plumber, for an electrician, for all of these trades that are integral to the industrial base. The challenge of where we hollowed out, though, is it's harder to replicate. It takes longer, both from a human capital and a capital equipment standpoint.
That was a masterclass and a phenomenal history lesson. And I think really astute observations. Hank, there's kind of two places I want to go with it. The first is, let's bring Amaero into the conversation, which is, this is a company founded in Australia now, but significant American presence, right? 100,000 square foot facility in the Tennessee Valley, American CEO of this outpost as well, and you guys are at the forefront of both advocacy and operationally robustifying and reinvigorating advanced manufacturing here at home. So talk to us a little bit about the roots of the company and how it came to be that you ended up as the CEO of this outfit at this time to serve this moment.
So let me take the question in reverse order, if you will, and that will tie in. So as I mentioned, I'm an engineer by education, but I spent my entire career in finance. Much of it, albeit I was living in San Francisco. I had an office in New York City and was back there 80 to 100 nights a year. As I progressed in my professional career 15 odd years ago, I began pretty much exclusively investing in private companies and growth capital in particular. And mind you, I'd been in the Bay Area at that time for 20 odd years, whatever it was, and up and down Sand Hill Road. A lot of the people I knew were in that business. And yet I was always taken by two things. There's certain areas of our economy and of the investment landscape that there's an abundance of capital. Okay, so today, if you're building a AI business, if you're in machine learning, if you're in certain areas, if you've got any pedigree whatsoever, there's no shortage of capital. And yet there's always good ideas where there's a dearth of capital. And I've always been attracted to those areas. Okay, those areas where there's not an abundance of capital. Partly from a return standpoint, I think it's a more attractive place to invest. And then moreover, I've got a bit of an edge. Okay, it's very, very, I think the markets by and large are very efficient. There's a lot of very, very smart people. I would rather compete against fewer of them than more of them, and thus going to these areas that are constrained in that way. That's number one. Number two, we've always invested in a way that's highly thematic. So in the early days of COVID, I bought a business from Bain Capital Ventures called Logic Source, run by a great founder CEO by the name of David Panino. And the premise was very simple. We were 10 days into COVID. I was scared to death what this would mean to the economy and the capital markets like everyone else. But it seemed to me that supply chains and procurement would matter. And this was a supply chain procurement business, right? So it was just a bet on a secular theme coupled with a bet on a founder and CEO. That business theme played out very well. We sold the business 23 months later to a New York City well-known private equity firm, FTV Capital, for 11 times multiple on our money. While I was waiting for that deal close, I was in Ukraine, the story that I told you. I came back from Ukraine and I set out to find an advanced material company because I had this premise again that we would undergo a significant reshoring of these critical industrial-based capabilities in the U.S. for the reasons that we discussed. I looked at 12 businesses, 11 of which were private, and then Amaero. Amaero was listed in Australia. I'd never invested in Australian business before. That was May of 2022. And I'll be quick to say, in every investment I've ever made, I've made plenty of mistakes, and Amaero is no exception. In every investment I've made, fortunately, I've also got lucky many times. Again, Amaero is no exception. And then somewhere in between, hopefully we've made a few good decisions. And strategically, the most important decisions we made with Amaero is, it was a company that came out of Monash. So this now goes to the first part of your question. Monash University is a well-known university in Melbourne. It's got a great material science background. It's a great engineering school, and it essentially sits next door to the National Science Lab, CSRO. And additive manufacturing coupled with material science has a very, very strong footing in Monash. Amaero spun out of Monash in 2013. About the same time, Monash launched Monash Center of Advanced Manufacturing, which at that time, I believe, was the best resourced additive manufacturing lab in the world. And so in the early days of the company, they did a lot of commercialization. These 3D printing machines or additive manufacturing machines, it's not a machine that you plug in and turn on and print parts. These machines have very complex parameters, and you've got to arrive at a parameter set, and that parameter set varies by alloy, it varies by conditions. And so that's really the science and the art, if you will, is optimizing parameters per alloy, per machine, per in part, and achieving the metal properties that you want. At the very same time, where there was a dearth was the powder that was needed, right, to supply all these machines, right, as the adoption of these was accelerating. And so that was the underlying premise of Amaero, was to go from commercializing end parts and manufacturing to producing powder. And yet I quickly determined, not unlike California, I'm sad to say, that Victoria, where Amaero is based, is not the easiest place to do business. It's a high regulatory environment. It's in a very expensive place to work. It's a place that construction takes a very long period of time. Again, very, very similar to Northern California, all of California for that matter. And so the first strategic decision we made was to relocate the business to the U.S. Today, albeit listed at AX, we are a U.S. company. We're majority U.S. shareholders. All of our employees, except for one administrative employee, are in the U.S. We have only a single administrative employee in Australia. And as you said, we're physically based in the U.S. outside Chattanooga, Tennessee. The next strategic decision we made was we hired what I think is the single best operating team in powder metallurgy. And we decided to focus very specifically on an area called refractory metals or refractory alloys. Refractory alloys are certain elements in the periodic table that have properties that are conducive to very, very high temperature environments. Okay, so think back to your chemistry days, niobium, rhenium, molybdenum, tungsten. It's these type of elements. And the reason for that is, if you look right now, we've got this generational investment cycle. And what's highly unusual, you happen to have two of them in parallel that are unrelated. So on the defense side of the economy, we've got hypersonics and we've got strategic missiles. Hypersonics, to the extent the viewers don't know, is a technology that was invented in the U.S. about 20 years ago. But unfortunately, we were slow to develop the technology. And unbeknownst to us, Russia and China got way ahead. And about 6 or 7 years ago, surprised us when we came to find they already had both offensive and defensive capabilities that we did not have. And to this day, we do not have. So it's enormous vulnerability, the likes of which we've never had from a defense standpoint. And thus the race is on in the U.S. to develop a series of hypersonic offensive and defensive capabilities. And this is a very, very high priority in the Department of Defense. Also, about 60 years ago, this is again the early 60s, we installed our first intercontinental ballistic missiles. It was a platform called the Minuteman. We've upgraded that several times. Today we're at Minuteman 3. And we're replacing that technology with something called Sentinel. And Sentinel will also be hypersonics. Hypersonics is broadly described as greater than Mach 5 or 5 times the speed of sound, which is really hard to even fathom, right? As you think about what it would be like to go 27,000 miles an hour, right? Which is what the speed of something, it's hard to even, right, fathom. So in both of those cases, because the friction on the surface at such high speeds creates incredible temperature, you've got to have these materials. Side by side to that, you've got a generation investment in the space economy. Both launch systems and satellites, there too, they're operating in these same very harsh, high temperature environments, and thus the need for these refractory alloys and these other specialty alloys. And that's where we've been focusing.
Yeah, I mean, you talk about the timing here. First of all, it's a fascinating story. Your background in finance and then coming into the operating role isn't something we see a lot of, especially in this industry. I think it's it tends to be one that's harder to break into, or you see a lot more. I guess manufacturing is a bit different, but in defense, folks generally find kind of operators who've owned the mission. Your knowledge is so rock solid. It's clear. I know you jokingly said you're slow learner, but it's very clear you're about as knowledgeable as anybody you'll meet in this industry. The tie into the defense ecosystem, and obviously this podcast, Crossing the Valley, is about how we've taken, or how companies and government organizations take capabilities, small capabilities, pilot them, and actually get them to production. You've talked about, you touched on two of the key kind of macro or secular focus areas for defense, both in hypersonics and then in space launch. Riding the wave right now, I think space is probably a little bit ahead of where hypersonics are domestically. But what does your business model look like for those industries? It's interesting that they are coming of age today, as opposed to you're having to disrupt a large installed base, even on the space side, where we've done space launch for 2 generations now. The technology that's being used today for reusable rockets and satellite buses and things is fundamentally step change different than where it was before. So how have you all kind of gone to market against that backdrop?
So what we try to identify is where you have this inflection point coupled with these convexity of circles of, on one hand, you've got certain technology that are at a tipping point of adoption. And what I would point to there is additive manufacturing. So I mentioned the space and the high temperature material. Something called C103 that I referenced earlier is a niobium alloy. It's about 90% niobium, about 9% hafnium. And again, this is it was patented 6 decades ago. It's been used for a long time. It was on the Apollo lunar landing vehicle. Okay. But of course, back in the 1960s with the Apollo lunar landing vehicle, we didn't have additive manufacturing. So when they were using C103, it was essentially in sheet metal form and it was being machined. Okay. And the challenge with that is the lead time to make those parts, not to mention if you're using casting or forging, other things, coupled with is something known as a buy to fly ratio. So in traditional subtractive manufacturing, you've got to buy 20 kg of material to get a 1 kg part. That is, you machine away about 95% of the material. We're now talking about a material that costs about $3,000 per kg, right? This is a very expensive material. You don't want to waste 95% of it. On top of that, the benefits of having an iterative design cycle and a more shorter production cycle have a lot of benefits. And that's where additive manufacturing comes in, right? The ability to print this part, to iterate the design. Essentially, you take a CAD file, right? A computer-aided design file, and then the machine prints that part. In addition to that, what's happened is the complexity of the geometry of these parts has changed a lot. So here we are talking about hypersonics, or satellites for that matter. Think about a leading edge, and I mentioned in this very, very high temperature environment with a lot of friction. So today what we do is we have these integrated cooling channels. These micro pores, if you will, that we can run fluids through to cool. It's not possible to cast or forge that part. The only way to make those integrated channels is to 3D print that part. So on one hand, you've got this adoption of technology. And then on the other hand, you've got this unmet need in the supply chain. And this, I would say, would be the big idea. And the big idea, I think, from entrepreneurs, Amaero is a relatively small company, right? Amaero today has a market cap in the order of $220 million, which relative to big industrials is a relatively small, young company. So we can't compete against big industrial opportunities that have big balance sheet needs, if you will. And we focused instead on specialty opportunities. So lower volume, higher value, and yet where there's a real critical need and a missing link, if you will, in the supply chain. And it so happens powder in the supply chain, which again is the predicate material for 3D printing, and particularly for these specialty alloys, we're undersupplied in the US. There's a notion I would touch on very quickly that many of your viewers probably know this, and many of them perhaps better than me. To insert new technologies, you've got to satisfy something called TRL and MRL. So technical readiness levels or manufacturing readiness levels. And one of the key determinants of that is, do you have a redundancy of a U.S. domestic supply chain? So in areas where we only have one U.S. domestic supplier, which is the case, for example, in these specialty powders, you don't qualify for MRL, right? You can't insert these technologies until you create a more robust U.S. domestic supply chain. So there, too, we've tried to really hone in on those opportunities.
Yeah, so I appreciate that definitional reminder as well. Technical readiness levels, I think something a lot of companies that do any kind of business with the Department of Defense and the federal government have to be familiar with. Manufacturing readiness levels is probably less familiar to some of our listeners, but no less important, and perhaps even more so, I think the idea of supply chain resiliency. When you talk about what is supply chain resiliency, what are we referring to? not being able to sell a good to the federal government unless there are multiple suppliers for the same good almost flies in the face, because you think about the primes and consolidation in the defense market. There's only one supplier for many of the end products. There's only one F-35 prime. And yet what you're saying is almost every component that's on that plane, that's on that platform, theoretically, needs to have multiple supply chain
the
redundancy.
Capability to choose from multiple suppliers. And that's exactly right. That is exactly right. And so in many cases, particularly in DOD, you end up with oligopoly, duopolies, right? You end up with concentrated power. You can't justify. And of course, part of what we also saw in the 70s and 80s, we saw incredible shrinkage of the DOD and the industrial base, right? Our defense industrial base. We went from, I don't know what the number was, but dozens of primes to a handful of primes. Enormous consolidation that we saw. And you saw the same thing within the suppliers. But on top of that, as we've evolved into new technologies, we haven't built up the supplier base that support these new technologies. Powder being is but one example.
So what do you think? If we fast forward 10 years, 15 years, let's say there are 5 major primes today, in 10 years, do we have 3? Do we have 15? Do we have 100? Do we have 5? What do you think?
So the challenge of why you have 5 and not 50, is these are very long cycle contracts. And unlike developing and selling a new consumer electronic, which if you put in the market and it fails, only the result is decline in sales, right? There's not necessarily a catastrophic result of that failure. Very, very different when you're talking about mission critical systems such as defense. And so when we develop these, we develop over very long cycles, and a product must go through a development phase. It must go through a demonstration phase, and only then does it even go into production. The challenge is it's very expensive to put together a protocol and go through the defense and demonstration phase with no guarantee you're going to get to production. And so on one hand, having the government as a customer is a lucrative customer. On the other hand, and we just saw this with I believe it was RTX just announced that they were exiting space last week for U.S. government contracts, if I recall. I think it was RTX that announced that. And they announced that in their government space programs, I think it was $23 million that quarter they had lost. I don't quote me on that number. But it's not a proposition that a small company like us could take that risk. And that, you talk about crossing this valley and the challenges of how do you get to commercialization? How do you get to where you're viable from a balance sheet standpoint? You can go through these cycles with DOD and working with various DOD labs, and then finally the end prime customers. And that's why I think for a company such as us, to have a specialty focus, to have more of a niche focus, we're not going to go compete against a prime. We just want to be a key trusted supplier. And there, I think you'll have a proliferation of those suppliers. I don't necessarily think we'll go back from 5 to 24 primes. I don't think we need to. But we must have a more robust, as you described, the resiliency in the supply chain will come from a more robust supplier base, and in particular, U.S. domestic suppliers. A lot of those suppliers today are not U.S. domestic suppliers.
It's a key point. And there's, there have been studies on this where there's actually more companies leaving the federal market each year than joining, which is strange given all the hype and the attention to the few at the top who raise a lot of money and go after these big targets. There's still more companies who exit that market. Hank, what I do want to hit on, because you guys do occupy kind of a different niche than many of the companies we've had on here, in that you're not selling directly to the federal government. You're a trusted supplier. What does that process look like? How do you become a trusted supplier, whether it's to the big 5 or to others along the way? What does it take to get a company like that to be able to take a bet on a company like Amaero?
Yeah. So the first thing that I would add, and I think this is applicable to any business, is we've got to be a valued, trusted partner, period. So at the end of the day, that's what I sell. At the end of the day, we've got to become a valued, trusted partner. And there's a lot of ways we can do that. Obviously, we have to have a high quality product that is the end demand, right? The end unit that we're selling. But along the way, we've got to get on the team and we've got to add value. And so there are ways that we've tried to do that. And if you think about our ecosystem, it's multi-pronged, right? You've got from a funding standpoint, many of these fundings are non-dilutive federal grants. And so you've got representation on Capitol Hill. You're dealing with congressmen. You're dealing with senators. You're dealing with federal departments, if you will. At the very same time, to the extent it's a defense contract, you then have a lot of the early and development work being done in labs. And whether that's a DOD lab such as Army Research Lab or Air Force Research Lab or Naval Nuclear, or whether that's a Sandia or an Ames, those are important partners, right? And we want to be valued by them. We want to help them advance their critical projects. And then finally, you've got the defense primes that we talk about, whether it's a Northrop, whether it's a Raytheon, whoever it might be. And then underneath that, you've got the supplier base. And so part of the reason it's a challenge getting across that valley, as you described, is it's not a simple, straightforward sale. And on top of that, it's a long cycle sale. But what we are trying to do is establish ourselves as a trusted value partner across that ecosystem.
I totally hear you. I mean, I'd love to go even a step deeper. So what does that look like? Do you do trials with these companies? You use small batch production? Like, what are the tools that you have to establish trust in a sales cycle?
So give you an example. Today, the supplier network for specialty alloy powders is very, very shallow in the U.S. It's essentially a single supplier today. And the challenge with that also is the nature of the production cycle is the lead time can be 12 months, 18 months, 24 months. We all read about the incredible pressure the various Department of Defense labs are under to advance these projects through development and demonstration. To do so requires test material. And yet, if you say, I've got a development alloy that I've down selected, and you call the sole supplier in the market and they say, we're happy to provide it to you in 18 months. We don't have 18 months. And so part of the way that we've developed our business is, how can I compete against this much, much larger competitor, who, by the way, is a world-class business? The way I've got to compete is I've got to find another way to add value. And one of the ways that I'm going to try to add value is we're going to build a business model we can be more agile, more responsive to the customer need. For example, this customer in a DoD research lab that needs these development alloys. The same with a tier one supplier. The same with a defense prime. So whether these are development alloys, whether this is working hand in hand with a 3D printer, there's some top tier suppliers that we work very closely with. We've got enormous respect for. And together with us providing the powder expertise and them providing the manufacturing expertise, right, we can help advance these projects more quickly and create more resiliency as well, as you would say, in the supply chain. So it all comes back to us is how do we advance our end customer's objective?
Yep. So it's some unique partnerships and just different ways of process is not altogether different. And many of the customers you're selling to probably look a lot like their end customer too, in terms of how they've organized internally.
Exactly right.
Yeah, it's insightful and it's a different spin on this kind of conversation than what we usually get to hear. So I appreciate you sharing it. I guess, Hank, as you think about what scale, you said Amaero is about 200 million by market cap today, smaller company. What does scale look like for you all? How do you think about the potential of this business and where you all are going?
So I worry less about the stock price and or market cap and or where it will be in a year or 2 years. What I want to focus on is, from a strategic standpoint, be incredibly myopically focused on having a strategy that satisfies an unmet need, that satisfies a pinch point in the supply chain, where we can solve for this friction, we can solve and remove this deterrence of insertion, for example, of additive manufacturing. Moreover, we focus specifically on a specialty market. So this is not a huge market. And as a result of that, the competitive environment as such is relatively attractive. And a company like us can stand up a value proposition. At the very same time that it's specialty, it's very critical and strategic. So it is a big enough market that we think we can build a material market cap. And moreover, the nature of where we are in the supply chain is so critical and strategic that whether it's from an M&A perspective or otherwise, I think it will be a very desirable asset down the road to others in the ecosystem.
So keeping strategic options open and available and on the table, just making it as attractive a company as you can. You guys recently announced a deal and some financing. Talk to us a little bit about that. What does that do for you as a company? Why is that a big deal?
Yeah. So in material businesses, in mining businesses, et cetera, it's not uncommon to sign offtake agreements, right? Where a company is committing to buy your material over a period of time. For us, standing up a new facility and being in a specialty area such as refractory alloy, what I felt was most important, more important than simply having a purchase order, was partnering with the right company from a technical expertise standpoint. And albeit we have not announced the name of the counterparty and we'll wait to do so until we qualify C103, it is a very, very big deal in that I think we have a commercial partner where we advance their commercial objectives and they will advance ours. But most importantly, back to this idea of being a value trusted partner to our end customer. I think, 1 + 1 = 3. That together we can address things, the resiliency of the supply chain, as well as capability and competency, that would have been more difficult as either of us to do it apart. So it's a very, very big deal, and more news to come later in this calendar year as we expect to qualify C-103. Because of the strategic nature of that, and by the way, these investors also don't know the name of that counterparty, but they know the nature of that counterparty. We are very, very gratified that we had essentially our first institutional capital raise. So the prior 3 capital raises, May of 22, December of 22, and December of 23, Pegasus Growth Capital, my private equity firm, had led. And we had been on order of 80% of the investment capital at each of those 3 raises. So we raised close to $35 million Australian, and we put in close to 80% of that. In this raise, what was important was it was led by Fidelity International, $10 million of the $20 million. Another very, very well-known Australian fund called IFM Investors, and a third fund, Cornerstone. Together, they were $17.5 million of the $20 million. And so it is a really important milestone for us, in that it provides affirmation, if you will, of the strategy, the scale of the opportunity, which you asked about earlier, as far as where can we go. And also importantly, though, the optionality that this gives us because we are so critical and because we are so strategic. So it's a big deal. And I was very, very gratified and candidly, humbled that the Fidelities of the world, invested alongside us and showed that conviction. Very appreciative of it.
Yeah, congratulations. Big deal. And appreciate you walking through it. We'll look forward. We'll stay tuned for the news on kind of as you announce who the partner is. I'm sure folks will be excited to figure that out. Hank, I know we just got a few minutes left here. You've got some big thoughts. We had the opportunity to talk a little bit even before today. We're at an interesting moment as a country. We're at an interesting moment from a policy perspective, socially. There's a lot of unrest going on among kind of younger folks on college campuses. There's a lot of churn right now. And I'm curious where you see this all going. You've got some big thoughts on the industry and on returning kind of dignity to jobs that used to be kind of the cornerstone of the American economy. What do you think about kind of the state of our political and education and kind of socio-cultural systems? Do you have optimism at this point? Are you a skeptic? Give us some big reflections on kind of where things are.
So by nature, I'm optimistic. And as difficult and as hard as the times appear to you and me, the solace is we've been in far more difficult places. You look at the aftermath of the Civil War and what our country went through. You look at the aftermath of the Civil Rights Movement in the 60s and what our country went to. You look at the aftermath of men and women coming home from Vietnam and the reception they received, right? So to you and me in our lifetime, this is as bad as it's been. It's horrible. And it truly does feel irreparable to me. And yet the hope I get is you look back over our country, the things that we've been through, and this center of gravity with these shared values and this shared culture. And if I have a worry, if we fray that shared culture and we fray that shared value, then I think all bets are off. And that's my worry. And without getting into a lot of personal views on that, I would tell you that I think it's one of the more worrisome things that we did in the 70s and the 80s to some extent in the aftermath of the Civil War movement was we took away the dignity of the job, right? In the auspice of doing good, i.e. the LBJ programs and something, we incentivize people not to work. And I think in our DNA code as a male in particular, so much of our self-worth is being a provider. And now you fast forward a couple of generations, how many children don't have a father when they come home at night? And these are foundational challenges to our country. And all these social policies mean well, but you've got to look through those social policies and say, are we really doing something good, right? Good for their family, good for their kids, good for the next generation. And the last thing that I would end on, I watch with sadness these events at the Columbia universities of the world today. And what I think one of the real consequences will be, and I speak for myself as an employer, I can almost guarantee you that next year, as employers receive applications from Yale and from Harvard and from Columbia and heretofore would have been considered the most prestigious universities in the country, I'm more likely to look stronger at the kid coming from a state school or the kid coming from Wisconsin or other great universities like a Michigan, and less so at these elite universities. And what we're all going to find is you've got hardworking, ambitious, kids at these other universities that maybe didn't have some of the same advantages in life that these kids that got into the Ivy Leagues and so forth went to. And employers such as myself are going to find an entire pool of talent that heretofore has been overlooked in these others. I don't know that it's hard to say something is irreversible, but I don't know that 20 years from now, going to a Columbia or a Yale means what it did when you and I were in college.
It's, you know what, that may just end up being a good thing. And I say that as somebody who has benefited from a number of those institutions, and I'm all for it, So he's Hank Holland. The company is Amaero. Hank, if people want to follow your journey, if they want to learn more about Amaero, where should they go?
So our ticker symbol is ASX, as in Australia Stock Exchange, 3DA. Our website is amaeroinc.com. And to the extent you care to reach me, hank.holland@amaeroinc.com. Really appreciate your time and interest, and thank you very much to all your listeners.
Thank you so much for being here, Hank, and appreciate your time. Best of luck with everything, and we'll be following closely.
Thank you. Take care, sir.